We're jumping to section 9.3, which is called vertex form. Now remember, form is just the shape, the way it looks, all right? The way the equation looks. So what kind of form did we just finish dealing with? We finished dealing with standard form. What was standard form? Standard form was y equals ax squared plus bx plus c. And today we're doing vertex form, all right? This is what it's going to look like now. Y equals, you still have an a, but you have parentheses after the a, and inside the parentheses you have x minus h with the square on the outside of the parentheses plus k. Now I know that sounds really weird, but this is going to make your life a lot easier when it comes to graphing parabolas, all right? It's also, you're going to have to memorize it, and the a value is the same as this a value up here. It still tells you if the parabola opens up or down. The b and c values are just numbers, and over here the h and k are also just numbers, but the h and k actually tell you the vertex, all right? So when you're looking for the vertex, it's simply going to be h comma k. So whatever number you have right here and whatever number you have over here, that's going to be your vertex x and y value. The only tricky part is that when you're looking at h, whatever you see, you're going to have to think opposite. So this minus sign is telling you to think opposite of whatever you see. So if you happen to have a minus 3 right here, your vertex x value is going to be a positive 3. If you have a positive 3 right here, your vertex x value is going to be a negative 3. All right, now that might be a little too much for the first minute of the lesson. Let's actually just go to a class opener and let's graph this standard form quadratic trinomial just to warm us up. Let's graph it the way we normally do. All right, so just in case you're having a brain fart, you forgot how to graph, the steps are right there on the board. I have them right here on the video. Step 1 is to find the vertex. How do you find the vertex? With the vertex formula, x equals negative b over 2a. Once you find the x, plug it in to find y. That'll give you the most important point of your parabola. You graph that most important point. Step 2 is to draw your axis of symmetry, the vertical line going right through that vertex, and it will be the equation x equals a certain value. And then step 3 is to use the xy table, or if a is plus or minus 1, you could use the pattern 1, 1, 2, 4, 3, 9. These are all steps that we've been working on for the past 2 weeks, graphing parabolas, and we're going to use that on this class opener, and we're going to learn a different way using vertex form. But anyways, right now, step 1 is what? Vertex. Yep, vertex. And the vertex is going to be a coordinate, and that coordinate is found by using the formula x equals negative b over 2 times a. And when you use the formula, use parentheses when you plug in your b and a values. So what is your b? B is negative 2. What's your a? Negative 1. What's your c? Negative 1. Nobody really cares about c. It's not in the formula. Anyway, the b value is negative 2. The a value is negative 1. And as you can see on the numerator of the fraction, a minus minus 2 becomes plus plus. And on the bottom, 2 times negative 1 is negative 2. So what you really have is x equals positive 2 divided by negative 2, which is negative 1. That's our x value of our vertex, negative 1. Now, how do I find my y value? Plug it in. So let's rewrite our equation. This y equals negative x squared minus 2x minus 1. Let's rewrite that, but instead of x's, let's just leave parentheses. That way we could plug in our x value that we just found, which was negative 1. So plug in negative 1 right there and negative 1 right there. And let me repeat, guys, this is where all students make mistakes, or not all, but many students make mistakes right here. They see a minus minus and they want to change it to plus plus. That is a total mistake. The rule, minus minus changing to plus plus, comes from multiplication. A negative times a negative is a positive. And we know we cannot multiply before exponents. PEMDAS says exponents before multiplying. So we're going to do the exponents first. Negative 1 squared is positive 1. And that negative that's in the front, we're just going to bring it down, put it right in front. So that's really a negative 1. Okay? And then over here, negative 2 times negative 1, we're going to call that a positive 2 and bring down the minus 1 at the very end. So you really have minus 1 plus 2 minus 1. What's your answer? If you owe $1, you have $2, and then you owe another $1, how much do you have left over? Nothing. 0, right? And if you're messing up on adding and subtracting, I feel sorry for you. No, use a calculator, right? Anyway, the vertex is -1, 0. Let's graph -1 on the x, 0 on the y. There it is. Step 2 on graphing a parabola is to draw your axis of symmetry. And that axis of symmetry might as well give the equation of that vertical line. The equation of that vertical line is what? Anybody? X equals -1. That's right. What else do we need? We need more points. So we either use a XY table, or we could use the pattern 1, 1, 2, 4, 3, 9, right? So I want to use input-output table, right? Let's plug in 0. If I were to plug in 0, that's the easiest number to plug in. Plug in 0 right here. What's your answer going to be? -1, the C value, right? So when you plug in 0, you get out a -1, and that's actually your y-intercept value. And I will be asking for y-intercepts, right? How do you find the y-intercept? You simply set x equal to 0 the way we just did, and you'll get the coordinate 0, -1, or you could just say -1. It crosses the y-axis at -1 right there, okay? Now we need one more point. What's another good number to plug in? 1, right? You want to plug in two values that are on the same side of your axis of symmetry. So the axis of symmetry is at -1. We plugged in 0, we got our -1. We plug in 1, let's see what we get out. When we plug in 1 right there, what's 1 squared? 1. With the negative in front, that's a -1. 2 times 1 is 2. With the negative in front, it's a -2. So I have a -1 and a -2, that's -3, and another -1, that's -4. So when I plug in 1, I get out a -4. I hope everybody sees that. I'm sorry for doing it all in my head. Use a calculator on a quiz so you can make sure you get that right answer of -4 when you plug in 1. Anyways, let's go to the coordinate, 1 on the x, -4 on the y. Let's put that dot right there. Now let's take those two dots, the yellow one and the blue one, and map them over to the other side of the axis of symmetry. The axis of symmetry is a reflection, right? So 1 unit away, 1 unit away, put a dot right there. And the other one is 2 units away, 2 units away, put a dot right there. And you have your awesome, perfect parabola that's opening down. And we're done. I guess we could state a couple of more things, because on the quiz this Friday, I will ask you a couple more things, like the domain. What is the domain? I have to say x equals all real numbers. If you just put all real numbers, you get half credit. You have to say x equals, right? The domain are your inputs, they're your x values. The range are your outputs. So what are we going to say? Y. Now, y is either going to be greater than or equal to, or less than or equal to, depending on how this parabola opens up or down. Less than or equal to, right? So let's put a less than or equal to, and it's going to be less than or equal to the y value of your vertex. So what's the y value of your vertex? 0. The y value of your vertex. Now think about it, guys. Like up here, this y level is 3, right? It's pretty high. This y level is 4. This y level is 5. This y level is 1. How high does this parabola go on the y level? It goes up to 0, and then it comes back down to the negatives. So that maximum value is 0, which means that the range, the y values of this parabola are at 0 or below. That's why its y is less than or equal to 0. I hope that makes sense. We've gone over this many, many times. So we're going to learn a new form today, vertex form. We already talked about it. It's going to make life a lot easier. Believe it or not, you see all this work over here and this work right here? We're going to be able to avoid all that with this new form called vertex form. Also, we didn't have to do this math on the XY table. You didn't have to plug in 0 and get out the -1. You didn't have to plug in 1 and get out a -4. Why not? Because if your A value is -1, you could use the pattern. Let me write it down here. 1, 1, 2, 4, 3, 9. Now remember, these are not coordinates. It's just a pattern from the vertex. So if you're at the vertex, you could go 1 over and 1 down. Why down? Because it's a negative. We know it's opening down. So 1 over, 1 down, you get to that yellow dot. If you go to the next one, 2 over, 4 down from the vertex. 2 over, 1, 2, 4 down, 1, 2, 3, 4, you get that blue dot. And with the axis symmetry, you map them over. So you really didn't have to do the math that we did on the XY table. Anyway, let's move on to today's main lesson, learning about vertex form, okay? So I just made a little chart here. I explained standard form, what we've been working with. We already know A, B, and C are just numbers. We already know if A is positive, the parabola opens up. If it's negative, it opens down. We even know that the A value affects how wide it is or how narrow it is. The closer the A value is to 0, the wider it is. Anyway, we also know that with standard form, to find the vertex, we have to use this formula, and we plug it in to find the Y value. Now, once you find the vertex, you could use a pattern, or you could use an XY table, or a modified pattern. The new form we're learning today, we need to memorize this. A is the same thing. A tells you if it opens up or down. H and K are just numbers, kind of like A, B, and C are numbers. H and K are just numbers. To find the vertex, you don't need a formula. It's called vertex form because if it's in this form, you're going to be able to see the vertex without doing any math. And I would like everybody to really focus in on this. To find the vertex, identify H and K, and the vertex is this coordinate, H comma K. All right? Now here's the important part. When identifying H, think opposite of what you see. Okay? When identifying H, think opposite of what you see. So, and once you find the vertex, of course, you use an XY table or the pattern to graph it. So as you can see from above table, the only real difference is that when it's in vertex form, you could easily state the vertex without doing any math. So check out number 1, guys, right here. Number 1. It is in vertex form. See, vertex form, you want to see those parentheses, and you want to see the power of 2. You want to see the power of 2 on the outside of the parentheses. Now, what is vertex form? Let me rewrite it for you right here. Y equals A parenthesis X minus H, close parentheses, squared plus K. Okay? So your vertex, it's telling you, find the vertex. The vertex is the coordinate what? Now, when you look at H, you have to think opposite because there's a minus sign here. So what is your, since your vertex is going to be your HK value, that's what we just learned on the notes above, what is our H value? Positive 7. Does everybody see that? Okay. Now, if you're looking for the H value, you look at this, but you got to think opposite of whatever you see. So the opposite of minus 7 is positive 7. Now the K value, it's plus K, so you take that for what it is. So what is the K value out here? 0, comma 0. And that's it. That's your vertex. You didn't have to do any math. You just look at it. So today's lesson, vertex form, it's beautiful. Why? Because you could just look at it and state your vertex without doing any math. You don't need a formula. You don't need anything. You just look at it, identify your H, identify your K. That's your X and Y value of your vertex. Take a look at number 2 right here, guys. What's the vertex right there? Vertex, negative 3, comma, negative 8. Yeah, remember, you only think opposite on H. You take K for what it is. All right, so remember that, guys. You think opposite on H, you take K for what it is. So we found the vertex. Again, no math. Number 3. Now this one's a little weird, and it's going to require some imagination. What do I mean by that? You see, vertex form, Y equals A parenthesis X minus H, close parenthesis, squared plus K. You need to see some parentheses, right? You need to see some parentheses. Are there any parentheses here? No. So we could pretend that there are some parentheses around the X, leaving the power of 2 on the outside, so it could look like this, right? Power 2 on the outside, parentheses. So when I ask you what number is being subtracted on the inside with X, what number is being subtracted in here? 0. Exactly. So the vertex H value is going to be 0. The K value is going to be what? 5. So our vertex is 0, comma 5. This was the H, this was a K. Not bad, huh? Now, the other option would have been, well, let's look at it. Oh, it's a standard form equation. The BX term is missing, so the B value is 0. You plug in 0 into the formula, plug in 2/3 for your A, and you'd get 0 for X. You plug in 0, you get out of 5 for Y. So you could have found the vertex with the standard form way, but it's easier to look at it in vertex form. Let's look at number 4 here. How about that vertex? What's that vertex? 4, comma, negative 1. It's easy, guys. All you do is think opposite on H, take K for what it is. Do you get it? Yes. Prove it to me. Isaac, number 5 right here. It's not on your paper. Let's just look at it up here. What's the vertex on that guy? You think, yeah, positive 1/2, opposite on H, and the K value? 1. Boom. Done. All right. Sophia, how about number 6? What's the vertex right there on number 6? It's not on your paper. These are just random questions that I made up right now. What's the vertex? Negative 2, comma, negative 9, right? Think opposite on H. That's why he said negative 2 instead of positive 2. And the K value, take it for what it is. Negative 9. You see a minus 9? It's going to be a negative 9. Got it? Valeria, how about this guy? Number 7. Excellent. Positive 1/5, comma, positive 1/2. That's the vertex, right? Vertex. Pretty easy stuff. Albria, how about that guy? Negative 23, comma, negative 25. Easy peasy, lemon squeezy. You got to love it, right? I hope you do. Why should we love it? Because, man, it makes things a lot easier. Now, we already know the steps. The steps are up here on the board, right? Find the vertex, draw your axis of symmetry, make an XY table, or use a pattern. It's the same exact steps. Find the vertex, draw the axis of symmetry, use a pattern, or your XY table, or a modified pattern. The only difference is you don't have to do that much math. Let's all take a look at this graph right here, guys. Step 1. What's step 1? Find the vertex. Okay, how about you guys tell me, what's the vertex on number 1 right there? A positive 1 and a positive 3. Let's all graph positive 1 on the X, positive 3 on the Y. There it is. Let's draw an axis of symmetry. That's step 2, right? Axis of symmetry. Draw the axis of symmetry right through that vertex. And now from there, let's state the axis of symmetry equation. X equals 1. But from there, you need more points, so you could use an XY table, or you could use the pattern 1, 1, 2, 4, 3, 9. We did the XY table on the other one. Let's go with the pattern on this one. So is this parabola going to open up, or is it going to open down? Down. Why is it opening down? Because the A value is negative. That's right. So it's opening down. So I'm going to go 1 over 1 down, and we're going to put a dot right there. And then I'm going to go back to the vertex and then go to the next part of the pattern, 2, 4. But again, back to the vertex, 2 over 1, 2, 3, 4 down. Put a dot right there. And then go back to the vertex and go to the last part of the pattern, 3 over 1, 2, 3, 9 down. 1, 2, 3, 4, 5, 6, 7, 8. Whoops, I'm off the graph. But you know what? I want to put the dot there anyway. You don't need it if it's off the graph. But let's map over these coordinates. So 1 unit, 2 units, 3 units. Again, this is 1 unit away this way. 2 units reflected over 2 units. 3 units reflected over 3 units. But you're off the graph. You don't even need these guys, all right? Let's just graph the ones that are on the graph. Here's our parabola. I could just put an arrow that makes it look like it's pointing towards that one to make it more accurate. And there it is, pointing towards that one. And that's our parabola. And of course, we need to state everything that we need to state, like what's the domain? X equals all real numbers. What's the range? Y is less than or equal to the value of 3, right? So all these different things that we need to state on the quiz you need to do. But right now we're just practicing vertex form, and it's really easy, as you could see, to graph. How about this guy? What's the vertex of this guy? Again, you need to use some imagination here. What do I mean by that? That's right. Inside those parentheses that aren't even there, the H value is 0. So the vertex at H value is 0. The K value is what? -5. So let's go to 0, -5, which is way down here, right on the edge of our 5-unit graph. The axis of symmetry goes right through it, which in this case is the y-axis. And if you wanted to give an equation for that green vertical line, you're going to say x equals 0. Perfect. And we need some more coordinates. So we could use the pattern, or we could use XY table, input-output table. Once again, I'm going to go with the pattern. What's the pattern? 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. So 1 over, 1 up. Let's put a dot right there. Whoops, let me go on blue. Go back to the vertex, 2 over, 1, 2, 3, 4 up. Put a dot right there. Go back to the vertex, 3 over, 1, 2, 3, 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9, way up here. Let's map over all these units that we have, all these coordinates. Right here, it's 1, 2, 3 units. 1, 2, 3 units. Put a dot right here. Let me do it in green. And the other one's 2 units away. Go 2 units away. Put a dot right there. And the last one is 1 unit away. 1 unit away would be right there. Connect your dots, and you have yourself a perfect parabola. I kind of went crooked right there, sorry. Anyway, don't forget, on the test, you're going to have to state everything, right? Should I state everything on this one? Just for funsies? Sure, why not? What's the y-intercept? Because I am going to ask you for the y-intercept. Where does it cross the y-axis? You could even see it. Where does it cross the y-axis? At -5. Now, you could say -5, or you could say 0, -5. And you didn't even have to see it. You didn't have to see that it crosses here. You could have said, oh, to find my y-intercept, I set x equal to 0, and my output will be my c value, -5. What else am I going to ask? The domain and range. So for the domain, you're going to say x equals all real numbers. For the range, you're going to say y is what? Greater than or equal to the y value of your vertex. What's the y value of your vertex? How low does this parabola go? Down here, and then it goes back up. Where is it down here? -5. The y value of your vertex is -5. So y is greater than or equal to -5. And that's about it. That's all I'm going to ask. The y-intercept, the domain, the range, the axis of symmetry is x equals whatever the x value of your vertex is. Let's try another. All right, Caden, what's up? Vertex. -3, comma, -5. It's too easy, right? Let's go to the -3 on the x. 1, 2, 3. -5 on the y. 1, 2, 3, 4, 5 down here. Second step is to draw your axis of symmetry. That equation of that axis of symmetry. What's the equation of that axis of symmetry? X equals -3, whatever your x value of your vertex is. After that, we need some points, so you could use an XY table, or you could use a pattern, 1, 1, 2, 4, 3, 9. 1 over, 1 up. Why am I going up? Because the a value is positive. If it were negative, I'd be going 1 over, 1 down, but it's positive, so I'm going 1 over, 1 up. Let's put a dot right there. Let's go back to the vertex, go 2 over, 4 up, 1, 2, 3, 4, put a dot right there. And go back to the vertex, go 3 over, 9 up, 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. Map everything over to the other side of your reflection line called the axis of symmetry, and you'll get this one 3 units away from it, this one 2 units away from it, this one 1 unit away from it, and I'm done. Man, I'm not drawing that good, sorry. But that's your parabola. Stating everything we need to state. Domain, x equals all real numbers. Range, y is clearly above a certain value, the y value of your vertex. So y is greater than or equal to the y value of -5. What else? The y-intercept, you could set x equal to 0 and solve, or you could just look at where it crosses the y-axis. Either way, your y-intercept is what? -5. That's right. So there's a point, there's another point, there's another point. Graphing, that's another 2 points, I think. The axis of symmetry is down here. There's another point right here stating your axis of symmetry. So you're going to get lots of points, multiple points for each of these graphs. You need to be able to state all these things on Friday's quiz. Last 2. So this guy, pretend that there's some parentheses around the x. Leave that negative out in the front so that the a value is -1. And let's identify our vertex, which is a coordinate hk. What's the h value? 0, because there is no number inside the parentheses with the x. How about the k value? -1. So 0, negative 1 is right here. Let's draw our axis of symmetry. That axis of symmetry equation is x equals 0, which is actually the y-axis. Let's find some more points. You could use an xy table. You could plug in 1, do the math, subtract 1, get an answer. You could plug in 2, do the math, subtract 1, get an answer. Or the easier thing is to recognize that the a value is negative 1, so it's simply going to open down with the pattern 1, 1, 2, 4, 3, 9. So opening down, 1 over 1 down, and then go back to the vertex 2 over 4 down. 1, 2, 3, 4. You're right on the edge. And that's it. Just map them over to the other side. Right here and there. Right? 1 unit, 2 units, 2 units. Connect your dots, you have your amazing parabola. Wow, you know what? I just realized we've been missing a certain detail that I will be asking on the test. I forgot to mention, not only am I asking for y-intercepts, but I'm also going to ask for x-intercepts, right? Where the parabola crosses the x-axis. Just give me a decimal approximation, right? So let's actually go back to the ones we've done. So like right here on this guy, for the x-intercepts, a decimal approximation, here's 0, here's negative 1, so maybe like negative 0.6. Negative 0.6 or negative 0.6. Or how about right here, where does this cross? Here's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So negative 5.4, negative 5.5. So negative 5.3, I don't know. It doesn't matter. Negative 5.4. So those are your two x-intercept values, right, for that one. How about this guy? What are your x-intercept values on this guy? Negative. All right, so if you say negative 1.1, that means it's a little bit more than negative 1. But you're saying a little bit less than negative 1, right? So, negative 0.7, 8. Yeah, those are great. And you don't even have to say negative 0. I mean, you could say negative 0.8, or you could just say negative 0.8. Either one's good. How about the other one over here? 2.9, 2.8, all right. And again, these are approximations. Unless they're nice, clean values. Sometimes you do get nice, clean values on the x-intercepts. How about this guy? What would we say these x-intercepts are? Crosses where? Negative 2.1, negative 2.2. And how about this guy over here? 2.1 or 2.2, right? So those are my two x-intercepts right there. So I will be asking for x-intercepts. Don't freak out. Just look at your graph and give me a decimal approximation. And that's on Friday's quiz. I've been forgetting that. Sorry. Last one on the front side here. Man, this is a ridiculously long video, but I'm hoping everybody's really comfortable with this after we're done. Vertex. What's my vertex? Negative 1, comma 0. Perfect. Negative 1, comma 0. H and K. There is no K value that's being added or subtracted, so you could imagine that there's a plus 0 out there. And the H value of plus 1, you got to think opposite of it. That's why it's actually negative 1. So negative 1, comma 0, that's our vertex. Step 2 is draw your axis of symmetry. And man, all of these graphs on this worksheet have had the A value of 1 or negative 1, which means we could use a pattern on all of them. Super easy, right? So if I go 1, 1, 2, 4, 3, 9, 1 over, 1 down is right here. Go back to the vertex, 2 over, 4 down is right there. And the other one's going to be off the graph. If I go 3 over, 9 down, it's going to be off the graph, so I'm not going to worry about it. I'm just going to map over those two dots right there, and I am done. There's my parabola. Let's state everything we possibly can. X-intercept values, where do they cross at? So you're telling me that it crosses the x-axis at negative 2? Negative 1. And this one only touches at one spot, huh? So you don't have two different x-intercepts. And that's okay. The x-intercept is negative 1. You could give the coordinate negative 1, comma 0 if you wanted to, right? Because that's the location of this dot. Or you could just say x-intercept is negative 1. I know that you're telling me that it crosses the x-axis at negative 1. Anyways, how about the y-intercept value? The y-intercept value is also negative 1, right? it crosses right there on the y-axis. Okay, you could have given me the coordinate as 0, negative 1 if you wanted to. How about the domain? X equals all real numbers for full credit. How about the range? Y is less than or equal to the y value of your vertex. What's the y value of your vertex? 0. The y value of your vertex, look guys, the y value of your vertex. X is negative 1, y is 0. So, and that makes total sense, right? This is the y level of 3, y level of 4. Here's the y level of 0. This graph was down here at negative 4, negative 3, negative 2, negative 1, 0, and then it came back negative 1, negative 2, negative 3, negative 4. So it definitely has a max value at 0 on the y's. So that's why y has to be less than or equal to 0. And finally, the axis of symmetry equation, A of S. What's the axis of symmetry equation? Come on, people. X equals negative 1. If you just put negative 1, you only get half credit. You have to say X equals negative 1 in order for it to be a vertical line. Okay? And that's about it. Check this one out. I think I skipped one. I did. What are the x-intercepts of this guy? What if I told you, hey, state the x-intercepts of this guy? What do you say?
0.
So you're telling me they cross at 0?
No,
The x-axis?
It doesn't cross.
It doesn't cross. So let's say does not cross, right? Or doesn't exist.
NA.
Or NA, yeah, because it doesn't actually cross the x-axis. Anyway, that was a long lesson, but I hope we learned everything we needed to learn here. On the back side, we have our homework. So let's get that started. I'll make a separate video explaining that.